So yesterday we were talking about adding fractions with unlike denominators, and today we are going to be subtracting fractions with unlike denominators. And if you see off to the side there on the left, you can see that the directions are almost exactly the same. There is only one thing that's different between yesterday's notes and today's notes. And that is one word. Subtract. Okay? So everything we did today is exactly the same that we're going to do today, or yesterday, except for instead of adding, we're going to subtract. Okay? So we're going to do the first problem, 4/7 minus 1/3. And I should have put up here because I don't want us to forget that we need to estimate. We should always estimate to see if we have a reasonable answer. Okay? So if I'm thinking about 4/7, I want to think about what's half of 7. Well, if I know 7 divided by 2 is definitely going to give me 3, right? And that's going to give me a leftover. So half of 7 is 3.5. Okay, so half of 7 is 3.5. Okay, so that means that 4/7 is really close to 3.5/7. Okay, which is the halfway point. All right, so I'm going to say that this is a half. It rounds to a half. If I have 1/3, well, 1/3 is one piece away from being a 0. So I'm going to say that that's 0. Well, 1/2 minus 0 is 1/2. So my estimate is 1/2. My real answer has to be close to 1/2. So next thing I want to do is find my LCD. So I need to find the multiples of 7 and 3. Again, please use your multiplication chart if you do not know these. So for 7, I know it's 7, 14, 21, 28, 35. For 3, 3, 6, 9, 12, 15. Now, I haven't seen any repeats yet, so I'm going to keep going. 18, no. Next one is 21. Oh, there we go. Now I have a common denominator, and that's the lowest common denominator. Okay, so my LCD is 21. So I did this, and I did this. Now I change to equivalent fractions. So I need to change 4/7 into 21ths. And I need to change 1/3 into 21ths. Okay. 7 times what is 21? Well, 1, 2, 3. What I do to the bottom, I do to the top. So 4 times 3 is 12. 3 times what is 21? 1, 2, 3, 4, 5, 6, 7. What I do to the bottom, I do to the top. 1 times 7 is 7. So now I want to add 12 21ths plus 7 21ths. Oh, excuse me, pardon me. We're subtracting today, aren't we? We are. I need to pay better attention. All right, so now I need to subtract. Remember, I only subtract across the numerators now that my denominators are the same. Okay, well, 12 21ths minus 7 21ths is 5 21ths. Okay, so now I am down here to simplifying. So I have to ask myself some questions. Okay, 5 is prime. 21 is composite. Remember, 7 times 3 is 21. Okay, so it's composite. So over here, when it's prime and composite, I ask myself, does one fit into the other? Does 5 go into 21 equally? No. So I am done. Okay, so 5/21 is my answer. All right, so I'm going to clear, and we're going to do one more problem together. Okay, this time I'm going to do 5/8 minus 1/4. Okay, actually we're going to do 2 problems because I want you to see it 3 times. Okay, so this is the second one. So I'm going to estimate 5/8. Well, I know that half of 8 is 4. So 5/8 is very close to that. So I'm going to call this, I'm going to round that to a half. Then 1/4, I know that that is 1 piece away from being 0. So I'm going to say that my estimate is 1/2 minus 0, which is 1/2, which was exactly what the last one was. Okay. All right, so the next thing I need to do is I need to find the LCD. Some of you might be able to tell me what the LCD is right now. Okay, I'm going to do my multiples. Okay, so for 8, it's 8, 16, 24, 32, and 40. For 4, it's 4, 8, oop, there we go. There's my LCD. Do I need to continue on? I do not. Okay, and so some of you knew that right away because you were looking at the 8 and the 4 and you knew that 4 goes into 8. And remember, if one of those denominators goes into another, then I can make it that number. So 4 goes into 8, so that means 8 is the common denominator. Okay, but I can always write out my list of multiples or check my chart to double check that. Now that I know my LCD, I'm going to change to equivalent fractions. Well, if I'm changing to eighths, this is already into eighths, so 5/8 is 5/8. Okay, so I only have to change this one. So 4 times what is 8? Okay, and then what I do to the bottom, I do to the top. So 1 times 2 is 2. All right, so now I have my equivalent fractions. Now I subtract across my numerators. So what's 5/8 minus 2/8? That would be 3/8. Okay, and now I have to ask myself if I need to simplify. Well, 3 is prime and 8 is composite. So remember, the question is, can 3 go into 8 evenly? You are correct, it cannot. So my answer is 3/8. Okay, now let's evaluate that with our estimate. Is 3/8 close to a half? Yes, because if I were to do a number line, this would be 0/8, 8/8, half would be 4/8, and 3/8 would be right here. So it would be close. It's only 1 piece away from being a half. All right, last one we're going to do together. 7/8 minus 1/3. So let's first estimate. So I can see 7/8, well, it's only 1 piece away from a whole. So I'm going to round that to 1. 1/3 is only 1 piece away from 0. So 1 minus 0 is 1. My estimate is 1. Next, I find my LCD. So think for a minute of what you think 8 and 3, what the LCD would be there. All right, let's prove it. So the multiples of 8 are 8, 16, 24, 32, and 40. The multiples of 3, 3, 6, 9, 12, 15. Well, I don't see any yet, so I'm going to continue down here. 18, no. 21, no. 24, yes. So 24 is my LCD. Okay, and I know some of you figured that out right away because you were multiplying 8 times 3 to get 24, and that's how you figured out that LCD. Okay, remember that's always going to give you a common denominator. Okay, it's not always going to be the lowest. Okay, we lucked out this time. This time it is the lowest. Okay, but sometimes it's not the lowest. So just keep that in mind. If you are always using that, oh, I'm just going to multiply the two denominators, you can do that. But remember, if you don't have the lowest common denominator, you absolutely will have to simplify. Okay. Now that I know my LCD, I want to change to equivalent fractions. So I'm changing to 24ths. 8 times what is 24? Well, 1, 2, 3. What I do to the bottom, I do to the top. So 7 times 3 is 21. 3 times what is 24? Well, 1, 2, 3, 4, 5, 6, 7, 8. 3 times 8 is 24. What I do to the bottom, I do to the top. 1 times 8 is 8. So I have 21 24ths minus 8 24ths. Okay, remember I subtract across the numerators. Since I now have the same denominator, that stays the same. Well, what's 21 minus 8? That would be 13. Good. Okay, so now I have some questions to ask. Okay, so 13 would be what? Prime or composite? That's prime. And 24 is composite. So then the question is, can 13 go into 24 evenly? No. Okay, so 13 24ths is my answer. Okay, so let's evaluate that with our estimate over here. Is 13 24ths close to 1? It's kind of a tricky question, isn't it? Because if I do a number line, this is 0 24ths, this is 24 24ths. What is half of 24? Well, half of 24 is 12 24ths, right? Which means 13 24ths is probably right here. So wouldn't that be closer to a half? Absolutely. And I think what's happening is because this 1/3, you know, that's really tricky on a number line if you're trying to round 1/3, okay? Because it's very small denominators. So it means my pieces are much bigger. So my actual half of 3 would be 1.5 thirds, okay? Well, 1/3 would actually go about right here. Okay, and so it's half of a piece away from a half, but a whole piece away from 0. Okay, so I could have rounded this 1/3 instead of to 0, I could have rounded it to a half and done 1 minus a half, which would be a half. Okay, which would then say, yes, we're right at 1/2. But remember, when we're estimating that, we're just trying to get close, right? So whether we're at a half or a whole, I mean, we're in the middle, right? So we're still close. So our first estimate was 1 and the second one is a half. I'm still close to both of those, okay? If I had said that my estimate was 0, that's getting further away, Okay, so remember, estimating, we're just trying to get close. So it's okay if we're not exact on that.